Hello students, welcome back to the statistics class. In the previous session, we discussed about the various formulas which will help us to construct an index number. In today's session, let's construct an index number based on these formulas. So the first example, compute Laspeyre's, Paasche's, Marshall-Edgeworth's, Dorbish-Bowley's and Fisher index number for 2000 from the following data. In the table, 5 different commodities are considered and they name them as A, B, C, D, E. Instead of giving the name of the commodities, the alphabets are given A, B, C, D, E. These are the 5 different commodities or items taken into consideration. And 2 different years are considered, 1995 and 2000, which is your base and the current year. 2000 is the current year and 1995 will be your base year. After that, along with the years and the commodity, price and quantity values are given for these 2 years. Price for the year 1995 and quantity consumed in the year 1995. Price for the year 2000 and quantity consumed in the year 2000, which is listed in the given table. Your question is to compute all the 5 index numbers starting from Laspeyre's till Fisher's. Find all the 5 index number. Now in order to find the index number, as the formula of Laspeyre and Paasche says that you should find the product of the price and the quantity values. For Laspeyre's formula, quantity values of the base year are fixed. So the formula is sigma P1 Q0 divided by sigma P0 Q0. So you should find the product of P0 Q0, find the product of P1 Q0. So you should find the product of price into quantity values. Base year price multiplied by base year quantity, base year price multiplied by the current year quantity. Similarly, current year price multiplied by base year quantity, current year price multiplied by the current year quantity. So you should find the product of these 4. So in the solution part, draw one more table. In the first column, consider the different commodities which is given in the question. So under commodities A, B, C, D and E, include one more row to find the total values. In the next column, copy the data. 1995 is your base year and 2000 is the current year. So instead of writing it as price and quantity, use the notation. So 1995, since it is your base year, 1995 price values means base year price values. Base year price values are denoted as P0 and base year quantities are denoted as Q0. So second column, write the variable name as P0. So under P0, copy the data 6, 2, 4, 10 and 8. Next column, quantity values are given for the base year. So Q0, under Q0, 50, 100, 60, 30 and 40. Next column, 2000 price values are given. 2000 is the current year, its price values. Current year price is denoted as P1. So under P1, copy the data 10, 2, 6, 12 and 12. Next column, quantities are given for the current year Q1 and copy the data 56, 120, 60, 24 and 36. So this is the given data. Now in order to find the index number, in order to construct the index number, you should compute the product of price into quantities. So include 4 more columns to find those values. After that, in the next column, multiply base year price by base year quantity, P0 into Q0. So write the variable name as P0 Q0. Similarly, multiply the current year price with the base year quantity. First, base year quantity into base year price. Second one, the current year price into base year quantity. So P1 Q0. Similarly, find the product of P0 Q1 and find the product of P1 Q1. So in order to get the index number, you should multiply the 2 set of price values with 2 set of the quantity values as well, so that you will get the product of all these values. If you can't remember to find the product of these 4, that is, if you can't remember P0 Q0, P1 Q0 and so on, first write the 2 formulas, Laspeyre's and Paasche's. So in Laspeyre's and Paasche's, numerator and denominator, you will get 4 different products. So copy all the 4 different products here in the table and you will get the values, which is the easiest step. So if you are not able to remember the formula, write Laspeyre formula. For Laspeyre formula, you should find the product of P1 Q0 and you should find the product of P0 Q0. So write those two. And for Paasche, P1 Q1 and P0 Q1. So you will get 4 different products. After that, find the values, compute the values. P0 to Q0, so multiply the values. 6 into 50, that is 300. 2 into 100, which is 100. Similarly, compute the rest of the values and find the sigma P0 Q0. Find the total of P0 Q0. Similarly, compute the second set of values P1 Q0. P1 is 10, Q0 is 50. So 10 into 50, 500. 2 into 100, 200, and find the rest of the values. Find the sum total of that. Similarly, find the values for the other 2 columns and find the total of all the 4 columns that you have computed. After that, write Laspeyre's formula. The Laspeyre's price index number is, write the formula, P01 of L equal to, write sigma on both numerator and denominator. Since you are computing price values, it is P1 divided by P0, where Q0 is fixed for both numerator and denominator. Sigma P1 Q0 divided by sigma P0 Q0, which is multiplied by 100. After that, substitute in the formula, that is equal to 1900 divided by 1360, which is multiplied by 100. That is equal to 139.71. So Laspeyre price index number is 139.71. After that, you should conclude about the data. You should give conclusions for all the 5 index number that you are going to compute. So the first conclusion is, here the answer, the constructed index number is more than 100. As I told, 100 is the index for the base year. If you remove 100, the remaining value will be 39.71, right? So what is your conclusion? The prices in the current year increased by 39.71% as compared to the base year. One more thing I would like to tell you. Here, while finding the product values, while writing the variable names, that is P0 Q0, P1 Q1 and so on, always first write the notation of the price and followed by the quantity values. Because since you are finding the price index number, always price comes first followed by the quantity values. Which means here you written it as P0 Q0, P1 Q1 and so on. Don't write it as Q0 P0. Don't write it as Q0 P1. So always price comes first followed by the quantity, because you are finding the price index. So always the first priority will be given to the price values. Next one. The Paasche price index number is, write the formula, P01 of P equal to sigma P1 Q1 divided by sigma P0 Q1, which is multiplied by 100. Substitute in the formula, that is equal to 1880 divided by 1344, which is multiplied by 100. And the answer is 139.88. Then write the conclusion. Here the prices in the current year increased by 39.88% as compared to the base year. After that, write Marshall-Edgeworth formula. The Marshall-Edgeworth's price index number is P01 of ME equal to, in the numerator, write Laspeyre's numerator plus Paasche's numerator. That is sigma P1 Q0 plus sigma P1 Q1 divided by Laspeyre denominator plus Paasche's denominator, that is sigma P0 Q0 plus sigma P0 Q1, and multiply the formula by 100. Hope I am clear. So Marshall-Edgeworth's formula is Laspeyre numerator plus Paasche's numerator divided by Laspeyre denominator plus Paasche's denominator, and the formula is multiplied by 100. That is equal to, Laspeyre numerator is 1900 plus Paasche's numerator is 1880. Substitute that, divided by denominator plus denominator 1360 plus 1344, and multiply the formula by 100. That is equal to 3780 divided by 2704, which is multiplied by 100. And the final answer is 139.79. Conclude about the data. The prices in the current year increased by 39.79% as compared to that of the base year. Next one, the Dorbish-Bowley's price index number is P01 of dB equal to half into P01 of L plus P01 of P. Here there are two different formulas which is one and the same. Either you can use the simplified version or you can substitute the notations in order to get Dorbish-Bowley's index number. Here, since you computed Laspeyre's and Paasche's price index, directly based on those two values you can compute the index number. So, I am using the first notation or the first part of the formula. You can use the simplified version also, or you can use this formula also. So, half into P01 of L. So, that is Laspeyre's price index number is 139.71 plus P01 of P, Paasche's is 139.88. So, half into 139.71 plus 139.88, that is equal to 139.795. Conclude about the data. The prices in the current year increased by 39.795% as compared to the base year. Last one, the Fisher's price index number is P01 of F equal to square root of P01 of L into P01 of P. Substitute in the formula, that is equal to square root of 139.71 into 139.88, which is equal to 139.7949. Therefore, the prices in the current year increased by 39.7949% as compared to the base year. As you can see, all the five values are almost the same, but there is a slight difference in their decimal values, right? So the first Laspeyre index number is 139.71, Paasche's is 139.88, Marshall Edgeworth is 139.79, the next one is also 139.79, last one is also 139.79. The values are almost the same, but there is a slight variation, a difference between the decimal values of each and every index number. Why? Because the first limitation or demerit of index number says that index numbers are approximate indicators. So these are not the direct values, these are the approximate values. That's why the values which you are computing, it is quite similar, but there is a slight difference in the values. Therefore, these are not the exact values, these are the approximate indicators. So, there is 39% variation from the base and the current year, 39 point something, right? So, there is a variation which is, it is quite similar, but there is a slight difference between the values which is constructed here. Second example, from the following data, construct Dorbish-Bowley's and Fisher's ideal index number. Why Fisher index is called as ideal? Because mainly this is constructed based on the geometric mean value, which is the appropriate measure to construct an index number, because geometric mean is expressed in ratios and index number is all about the relative changes between the base and the current year. That's why Fisher index is called as, Fisher's price index is called as ideal index number. Here your question is to construct Dorbish-Bowley's and Fisher's ideal index number, which is price index number. Right? And in the table, 4 different items are given. For the notation 1, 2, 3, 4 is given, and the base year and the current year price and expenditure values are given. Now, price values means P0 and P1 value for the base and the current year. What is expenditure? Expenditure is same as value, right? How you value a product? It is based on the price and the quantity. If 1 kg of rice costs 30 rupees, then you are buying 1 kg of rice, the quantity consumed is 1 kg and the cost of the rice is 30. So 1 into 30, 30, that is the value of the product or the item, right? So here expenditure means again you are spending the amount based on the price and the quantity, right? You are spending 30 rupees for 1 kg of rice. The cost of the rice is 30 rupees and you are buying 1 kg of rice. So 1 into 30, 30, that is the expenditure. You spend 30 rupees for rice. So rice is the product of price into quantity. Expenditure means it is the product of price into quantity. So for base year, Price is denoted as P naught and quantity is denoted as Q naught. The product of P naught Q naught is P naught Q naught, right? So base year expenditure is P naught Q naught and current year expenditure will be P1 Q1. Current year price into current year quantity P1 Q1. So draw one more table in order to compute the 4 product values based on which the index numbers are constructed. So solution, here we must calculate the quantity values and then proceed to compute the index number, because in order to compute any of the index number you should consider both price and quantity. But in the given question the price values are given, 2 set of data for base and current year. Price for the base year, price of the current year is given, whereas quantity consumed is not mentioned in the data, right? Instead of giving the quantity values, expenditure is given. Expenditure means which is the product of price into quantity. So in the question, in the given question, first set of data is P naught. The second one is P naught Q naught. You don't have Q naught values. The product is given. Second part, P1 is given. Along with that, P1 Q1 is given, where Q1 is not given. So the 2 set of quantity values are not given in the question, which you should compute, right? So expenditure equal to price into quantity, which is already known, right? Now your question is to find the quantity values. So here rearrange the formula in order to find quantity. Quantity equal to expenditure divided by price. So from the given formula, expenditure equal to price into quantity. So in order to find quantity, divide expenditure by price and you will get the quantity values. Now in order to find the quantity, you should find the quantity values for the base year as well as for the current year. So draw one more table in the solution part. The first column contains the items 1, 2, 3, 4, include one more row to find the total values. Second column, base year price values are given, so denote it as P naught and copy the data 2, 4, 1 and 5. Next set of data, total expenditure. Expenditure is P naught Q naught. So the notation is P naught Q naught and copy the data 50, 20, 8 and 30. Next column, P1 is given, price for the current year. So copy the data 5, 8, 2 and 10. After that, expenditure for the current year, P1 Q1, product of price into quantity. The values are 60, 48, 20 and 70. Now the next step, you should compute the quantity values for both base as well as current year. So Q naught, according to the formula, quantity equal to expenditure divided by price. So first you should find quantities for the base year. So Q naught equal to expenditure for the base year is P naught Q naught divided by price for the base year is P naught. So the formula is quantity equal to expenditure divided by price. So Q naught equal to P naught Q naught divided by P naught. Based on this you can compute the quantity values. So first one is 50 divided by 2, P naught Q naught divided by P naught. 50 divided by 2 which is 25. Similarly 20 divided by 4 which is equal to 5. 8 by 1, 8. 30 by 5 which is 6. Now you got the quantity values for the base year. Similarly compute quantities for the current year. So in the formula substitute Q quantity value for the current year Q1. So Q1 equal to expenditure for the current year is P1 Q1 divided by price for the current year P1. Understood? Q1 equal to P1 Q1 expenditure divided by price P1. So Q1 equal to P1 Q1 divided by P1. Compute the values. P1 Q1 is 60 divided by 5. 60 by 5, 12. Next value 48 by 8, 6. 20 by 2, 10. 70 by 10, that is 7. After that, as usual, you should find the 4 different product values. One is P naught Q naught, which is directly given here. Just find the total of that. After that, find P1 Q1. The values are given in the question which you have copied. Find the total of that. And you should find 2 more product values. One is P naught Q1, other one is P1 Q naught. Find the values and then find the sum total of the respective column and complete the table. After that, your question is to compute or construct a Dorbish-Bowley's index number, right? So write the formula P01 of dB equal to half into. Here you didn't compute Laspeyre and Paasche, so use the the direct notations in order to compute the index number. If Laspeyre and Paasche was constructed or computed based on P01 of L plus P01 of P into 1 by 2 will give you Dorbish-Bowley's. But here, since it is not computed, use the notations and get the index number. So half into Laspeyre index number sigma P1 Q0 divided by sigma P0 Q0 plus Paasche sigma P1 Q1 divided by sigma P0 Q1 and multiplied by 100. Substitute in the formula, that is equal to half into 241 divided by 108 plus 198 divided by 93 and multiplied by 100, which is equal to half into, first divide the values. 241 by 108 is 2.2315 plus 198 by 93, that is 2.1290, which is multiplied by 100. After that, 1 by 2 into, add the two values and the total is 4.3605, which is multiplied by 100. After that, multiply all the three values and you will get the index number. So P01 of dB equal to 218.03. Now, in order to conclude about the data, as I told, the index number is more than 100, right? Which means the values are increased. So the conclusion is the prices in the current year increased by 118.03% as compared to the base year. I repeat, if you deduct 100 from the obtained answer, the remaining value will be 118.03. Therefore, the prices in the current year increased by 118.03% as compared to the base year. After that, compute Fisher's index number. Fisher's ideal index number is P01 of F equal to square root of Laspeyre into Paasche's formula. So Laspeyre is sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1 and multiplied by 100. That 100 lies outside the square root, which will not come inside the square root. Be careful. After that, substitute in the formula, that is equal to square root of 241 by 108 into 198 by 93 and multiply the formula by 100. That is equal to, first divide and write the answer. That is 241 by 108 is 2.2315 into 198 by 93, that is 2.1290 and multiplied by 100. After that, first take square root, first find the product, take the square root and then multiply by 100 and you will get the answer, that is 217.96. After that, conclude about the data. The prices in the current year increased by 117.96% as compared to the base year. Again, if you deduct 100 from the 217.96, subtract 100, the obtained answer will be 117.96. Therefore, the prices in the current year increased by 117.96% as compared to the base year. Here also the answers are quite similar, 218, 217. They are almost the same, but they are not the exact values, they are the approximate indicators.